As part of my effort to clear up some space, I've decided to get rid of a few of my old Apple collection items, namely the ones that are either not worth anything, too beat up, or simply are too large and awkward to ship anywhere, such as this original Apple scanner. Apple made a couple different scanners over the years. This is the original one, the Apple scanner, and then they made the One scanner, and they made a color version as well. This one is 16 shades of gray, and it's a normal, I think this is an A4 size sheet. It creates this wonderful green glow, which we'll take a look at. The fluorescent tube in it is this weird off green color, and yeah, it's this particular one's pretty beat up. I mean, the case is fine, it's just yellow due to the bromide fire retardant. It has one button on the front which is completely jammed. I think this is a button at least. It's a totally different color too. I guess it doesn't have the fire retardant. And yeah, it's just SCSI connection. And hang on, I'll grab the cables. SCSI terminator. And a normal Centronics 50-pin SCSI cable, which we really take for granted the fact that we use serial communications for pretty much everything now. This is parallel. You have to run many wires to the device. Look at the size of the cable. 5 megabytes a second. Yeah. Anyway, this is the computer end, DB25. I had to use my 20th anniversary Mac and install the software on that using a convoluted arrangement, since I have the 20th anniversary Mac in the living room. So it did work, and it actually runs the software in OS 9 without issue. And we'll just get this thing spun around and take a look before we start ripping it apart. Alright, around back we've got a little locking port. It's kind of cut off frame, but it just holds a little tab to bolt this thing to your desk. There seems to be a split down the case here. I think that's actually part of the design, because I think this bottom section comes off. Anyway, there's a SCSI ID selector here. You can select, what the hell, it goes up to 9. They didn't bother, I guess they didn't get a proper SCSI ID selector, because SCSI IDs go from 0 to 8, and you can't be 8? Yeah, you can't be 8. 8 is the address of the controller, and 0 is usually the address of your internal computer, or internal drive. Here's mains power input, and the two SCSI connectors, which one of them is missing its one of the little locking tabs. There's a connector here that Wikipedia says is a ADB port, which is wrong. ADB ports are what original Apple mice and keyboards use. This is actually the same design as it looks similar to their S-Video inputs, but what this is actually for is the transparency adapter. This, despite the fact that it has a local talk icon, I don't think you can actually hook up a serial local talk adapter to this. I think all it can accept is a replacement top portion, which allows it to scan the clear transparencies, and that's it. This is the fluorescent tube, and you can see there's actually a little access port here for it. I don't think I've ever actually opened this up, but if I apply power with the power switch on the other side, ooh, green. It does take a little while for it to power on. This eventually just does a little self-test and then turns itself off, as you can see. And yep, the lid is pretty standard. It has a height adjustment, so you can actually scan a small book. And it follows this kind of cool curve of the casing, like many Apple products of this time. This one actually has a little bit of a crack. Well, maybe not a crack. I think it's just a design weakness. Like, there's no support right here. First thing I'm going to try and do is take out the bulb so we don't break it while it's coming apart. Oh, cute. Okay, and this must Okay, there's a screw there. Probably has something to do with it. Not that it matters. We're going to be taking out just about every screw so I can replace or recycle this thing. Oh, it released the little pull latch. Let's see if this... I think I have to take the screw out. It's moving forward. Okay, I think that's it. Alright. It's a metal holder, probably for heat dissipation. 2 prongs on either end. Oh, hang on, there's some information on the bulb here. Let me see if I can get this out without killing myself. Made by Toshiba, of all people. It's the FL8R G54-7/70. It's got some Japanese characters on it as well. And yeah, just like looks like a basic bulb, but it's obviously unique to scanners of some description. And yeah, I might try and put this on eBay since these things do burn out. Maybe someone can use this. Put it up a little for like $10 or something maybe. Here's the holder for it. The thing is a very strong metal, the actual holder, and there's a 4-pin connector, and we've got wiring running to each side. It's just regular wiring. I guess it's not too high voltage. And yeah, it's got a little pull tab or pull handle, and it's also got this captive screw. And that's about it. Ceramic holders, I think. Oh, maybe they're plastic. I disconnected the top scanner lid, and there's just a couple screws holding it. It uses this little kind of clamping arrangement with threaded screws. This is kind of a standard scanner top. It's just got this reflective, white reflective stuff on it and foam, which is somehow not disintegrated after all these years. And yeah, a little spider nest. Who knows how old that is. And that's it. Nothing too interesting up here. So presumably you can take those screws off and replace it with the transparency adapter. I've never actually seen one in person, and I don't know if it was actually released. I'll add an image if I can find an image of it somewhere online, but I don't know if it was. It might have been one of those promised upgrades that never actually came. Here's the label on the underside. Apple Scanner. You know it's the original when it doesn't even have a model designation. I don't know if this was actually outsourced to another company. I know a lot of the other Apple non-computer items, such as the speakers, which were made by Bose, the Apple QuickTake cameras, which were made by both Kodak for the original and the 150, and the 200 was made by Fujifilm. I don't know if this was actually outsourced to another company, and you know, Apple just made the controller and the case, or if the whole module was outsourced, or if it was completely in-house. That might explain why it has the weird-ass green lamp. Although I'm not too experienced with grayscale scanners. They may all have that. I'm not totally sure on that one. Okay, there's obviously 2 removable panels here, so let's see what's underneath these things. There's a little bit of grill for airflow, but I don't know what's actually in these. I've never opened the... Okay, there's nothing here. There's just some shielding. This looks like it could hold some kind of stand adapter, but that wouldn't make any sense. I'm not sure what this is. Maybe this was for future designs. Maybe they expected to have some kind of module that would go underneath it. Well, let's get this big panel off. See what's under here. My cat is trying to get into the cupboard underneath the counter in the kitchen. He likes to go sit on the plastic bags. Neo, quit it. He won't listen. These might be captive screws too. The build quality of this thing is actually quite nice. They used decent parts. Okay. Yeah, they're They look like they are captive screws. So this is obviously the little bottom access panel. Gets us access to the board, which is shielded. Probably power coming in. Probably readout to the sensor. Probably for the power, not power switch, probably for the front panel button or something like that. I'm not sure. So let's see what else we can do. We can take off the shield. Take a look at the controller board. Oh, I hear bags rustling. He's in there. Damn cat. Oh, thought that took off the shield instead it's taking off the whole controller board. Oh, this one's not out yet, I don't think. There we go. Disconnect these. Oh, there I feel some ribbon cable. Just pull that out. I'm not going to be keeping this. Collect all the screws. Okay, here's the controller board up close. Just got some caps for filtering. Oh, nice Rubicon ones. And probably the main controller, Hitachi. It's most likely like a microcontroller by them. And an Intel chip and an AMD chip. This is probably a serial controller of some type. It's an AM5380PC, and that might be for the SCSI. And we've got some ROM or RAM, TEC controller. I think this board is probably actually made by Toshiba. There's also a big TEC power chip, probably the stepper controller. And not much else. We got look at the effort they put into this. There's actually a socketed connector going to the SCSI ID selection switch. There's a fuse here. Just a few controller chips, you know, some resistor packs. There is a connector here that hasn't been installed, along with slots for what are most likely more resistor packs. And not much else. It's, you know, fairly simple controller board. Not much on the back, just a few passives down here and a whole bunch of surface mount resistors. These are most likely for SCSI termination. And there's an interesting diode here with these huge blobs of solder on each side. I did eventually figure out how to get this stupid top off. The case is actually just plastic clipped on. This is the switch and LED assembly. There's two LEDs on it. I'm trying to figure out why this thing doesn't switch anymore. Oh, I see. It's like a rubber thing and it's like disintegrated. That would be why the button doesn't work anymore. Oh, it's just a scan power board. TEC. There you go. Everything's made by TEC in this thing. The actual top plate is just a relatively thick piece of glass and just some shielding along the edges. And we've got the little spring mechanism for the raising and lowering of the lid. And that's it. Now we're getting into the meat of the unit. Here's the little pulley system that controls the stepper motor and the movement of the actual scanning head. And the ribbon cable we disconnected from the board obviously goes to the image sensor. The white cable must have come from the power supply, which is over here under a nice metal grill. I'm starting to see why this thing's so heavy. I mean, one, there's a big proper transformer in here. There's a big linear transformer. I was expecting a switch mode, even though this is fairly old. I mean, I still figured there'd be a switch mode power supply in it. There's also metal shielding on everything. So this thing's kind of big. What I'm going to do is I'm just going to take it all apart and we'll look at all the pieces individually, because the case itself is just a plastic case. Nothing too interesting. Well, this is rather funny. I've taken out most of the equipment now and taken out most of the screws. So I'm like, okay, here we go. I'm going to get to the power supply now. There's some ferrite right here, so must be the Huh? What? This is just a grill that's going over the exit vent, probably for EMI interference shielding. But look what was hiding under a plate. A huge PCB with big drivers, probably hybrid ceramic drivers, big inductors, big filter cap. Here's the input circuitry. We've got mains filtering, and then an insulated line that runs over to the big power transformer. And yeah, I'm starting to explain the weight. Look at this inductor with the cool bolt. Very cool. I'm going to try and get this board out. The case is now empty. I've taken everything out. Turned out the big multi-way connector is what goes to the big driver board. And this is the input connector and the power switch. And look how nicely this is wrapped around this big chunk of ferrite. Ooh, they took time and effort. It's got like a nice little connection going to the board. Everything's heat shrunk. Very nicely done. You can see a shake-proof washer and everything on the grounding wire. Very, very, very nice. And this is just that grill that was covering up the panel. It's actually very tough. I might keep this for something. I'm sure I can use it somewhere for something. And one thing I noticed, I thought I had another one here. Maybe not. Oh, here we go. There were these oddly shaped pieces of metal in the case. And this one I think was here, up here. And this one was over here somewhere. And they're screwed in. And I was like, well, why would they run one piece of metal over? And then it obviously dawned on me, oh right, this thing is grounded. So they need to run grounding to everything in the case that needs to be grounded. So that means either running wire to everything, or in this case, they made a custom piece of metal to run from one board to the transformer, over to here, and so on. This is the stepper motor. This controls the movement of the actual scanner head. I think that's a Mitsubishi 39 SHM-32C6A, 16 ohms, and it's 3.6 degrees. And there's actually a date on this, November 9th, 1989. I was only 6. But, yep, it does run. And we've got just a simple multi-way connector that goes to the, I think this actually goes to the motherboard. So they must, it's weird, because the motherboard is sending signals to the stepper motor, but the driver board has all the power stuff on it, and it's running through to the motherboard first. So it goes between the motherboard. It's strange. I don't know if they're just carrying the signals across, or maybe these are doing something else, like these are some kind of weird amplifiers or something. I couldn't really find any information on these. Here's the power supply board. The input comes in here, and this goes off to the transformer. So this is just filtering, and then it gets reconnected way at the other side of the board. So it just does a little bit of filtering and sends it off to the transformer. There was a little cover over this common mode choke, and we've got some input protection. All the caps on this board are made by Marcon. I haven't heard of them, but they must be fairly good considering they're still going after all this time. No bulges in any of them. This is the main filter cap after the bridge rectifier. And this is the input to the from the transformer. Goes through bridge rectifier, then through the filtering and whatnot. The cap, some more fuses, probably controlling, or probably for the motors, or the motor. And these go off to the main board, I believe, and they've got little ferrite beads on them. This also goes to the main board. It's the main connector to it, and there's a little 8-pin dip socket chip here, which is a power management controller. It does like reset and power supply voltage supervision. That's what it said it did. There's also some missing spots for some stuff here, which they obviously didn't need. And we've got the two giant, most likely ceramic hybrid modules, which are an TCEC A051 and then the A063. I couldn't really find any information on those. I'll put in a nice little overlay if I did. And yeah, not much else on it. There's a transformer. I can't see any writing on it. It is very heavy. The cap that's hooked up after the bridge rectifier is 63 volts, so this might be like maybe 48 or 24 volts coming off of it. And there's a line that runs to a switch, and the wiring is a little weird here. I think what the switch is doing is severing the connection. I think it's like a safety off, because this connection goes in here and then back out into this, which goes to the main driver board. And this is the wire coming in from the right after the filtering at the beginning. It's actually got a metal screen type material on it. It's woven, and it's also got a fiberglass insulation wire insulation, just because it's running behind all the heat sinks and everything. Wouldn't want that coming off. And we've got a little micro switch here, which goes to the main board with this little 2-pin connector. Nothing too interesting. Well, I'm an idiot. If I'd bothered to look on this side, I'd see that it's actually a 28 volt connection coming off the secondary winding, and 120 in. Very heavy. I might keep this just because I need a transformer for a project. Alright, on to the last part, which is the scanner head assembly. As you can see, there's this big heavy metal rod that it travels along. Get this out. I'm sure they can recycle that. And this is just clamped on somehow. Well, looks like it comes off fairly easily. Actual pulley mechanism. There we go. Yep. Don't need that. It's actually a weird material. I haven't seen one of these of this material. Usually they're black. Maybe it's just the same stuff, it's just not colored. And on the board we've got, this must be the sensor board right here, and this little module must be the high voltage transformer for the fluorescent tube. So let's start getting this off. The connector here is for the fluorescent tube. Don't see any other screws. Okay, that's coming off. Say heat welded. How do you come apart? Oh, I think it's attached at the back here somewhere. Okay, I see 2 more screws, so this has to come off first. Somehow. I mean, I don't care about keeping it, so just... there. Yeah, it's got little press clips on it. So, take this board off. It's always funny how many times I slip off the screws when I'm filming, or drop my screwdriver, because I'm reaching around the camera. Makes it a little more awkward to do, so I'm usually kind of stretched out, and it's not how I would normally operate a screwdriver. Similar to soldering, it's very hard to solder on camera. Okay. There's the single line CCD sensor. Get to that board in a minute. I have voltage boards right here. Okay, let me take off these screws. Now there's a small lens here as well, which focuses the lines, the wide image of the actual object down to the size of the sensor. Kind of compresses it. It's just mounting. Here we go. There's the lens. I wonder what this It is kind of working. It's a very, very small aperture. You can see there's very, very little opening right in the middle of that lens, despite the fact that the glass is very large. And here's the mirror, which reflects the image back into the sensor. Just a small mirror. Oh, hello camera. There's also a secondary mirror here. It may be two-part, focusing it into it, and a third mirror here actually. A lot more optics than I expected in this thing. Here's the fluorescent starter. It's the TL8-2403. It's 24 volt. Again, it's made by TEC. And there's no screws on it. That looks like just a basic high voltage fluorescent transformer. Nothing too special in here. Oh, okay. I was going to say I don't think I'll bother taking it apart any further. But since it just bends apart, yeah, looks like it's even mostly just a hybrid module that's doing all the work. A few caps, probably MOSFETs down here. It's probably the high voltage transformer, or maybe this one. Not sure. They come in ones this big. This might just be a this might just be an inductor. I think it says IC. Yeah, I think that's the inductor, and this is the high voltage transformer. One thing I noticed about this lens is if you hold it right up to your eye, put something in front of it, it does actually provide a lot of magnification. I might keep it as a kind of like an inspection lens. Almost forgot to shoot the little part with the CCD module on it. I got distracted by my new used oscilloscope, a Rigel DS1022C off eBay. So that will replace my gigantic Tektronix TDS420A, which is just massive, taking up almost my entire desk. I'll probably make a video of the two at some point. I mean, I definitely want to make a video of the Tektronix before I try and put it on eBay. I don't have a box big enough, so it may be a little while. It's probably going to sit in the closet for a while. But this is the CCD driver board. If it wants to focus. It has the lovely ceramic package CCD. This is a line CCD sensor. It will inch along, and all the optics focus that 1 pixel wide beam of light into the sensor, and it reads it out step by step. It's got some 7/4 series logic, a couple MOS drivers, some ferrite beads, which are on every single board in this thing, some Rubicon caps, and not much else, just a flat flex connector. But yeah, that is the rather nifty CCD. I'm going to suck this off with my Heiko and keep it because it's pretty cool. And I just realized that my battery is down to 3 minutes remaining, so I should probably wrap this up. So that was pretty interesting. I didn't know what was inside that scanner. I've never opened it up before. So unfortunately now it is off to the recycling / trash. But it wasn't going to do anything anyway. As you can see, the scanner itself can't actually continuously scan. See? It's doing these little half steps and pausing. I think it's either buffering or processing the information every once in a while. The next shot I'll show the preview mode where it does a lower res and it can actually keep up with it and just run the stepper motor. But for a real scan at 300 dpi, it has to periodically stop. And it also takes like 35-40 seconds. Go! What I've done is I did manage to scan a few images on my 20th anniversary Mac. I first scanned just an envelope from Apple, a really old one. That address probably doesn't exist anymore. And I tried scanning a brochure. The brochure was actually in color, so it does come through in grayscale. Remember, this thing is limited to 16 levels of gray. And I also did one scan in the line art mode, one scan in the halftone mode, and one scan in the grayscale mode, just to show a little bit of the differences. Like, they're obviously designed for different things, not for the CD covers I was scanning, but it just shows kind of a drastic example of the differences. The app itself is fairly straightforward. It ran great on OS 9. It has a very tiny extension, like 5K worth of disk space, and the app itself is very tiny as well, and it's fairly basic. The one scanner uses different software. I don't actually have a one scanner, so don't expect a video for that one. And yeah, that's it.